We've looked at how to graph radical functions using transformations. I now want to look at constructing radical functions in a completely different way. And what I've got set up here is just a basic function, a line, y equals x plus 1. And I want to look at creating a radical function simply by taking the square root of an existing function. So I'm going to take the square root of this function that I have here. And what I want to look at is how do the y values of the original function change to become the y values of the new function. Because to get the y values of the new function, we're going to take x plus 1, which are all of these y values, and square root them. In other words, the y values of the new function, given the values I have set up here, would be this. For the given x values, these will be the new y values on my new function. Now let's just look at how these new y values compare with the old ones. Well, the first thing I'll notice is that the first two that I have here are the square root of negative values, which are undefined. And so what that's going to mean is that where I had negative y values on my original function, which is right here, there will not be any points on the new graph because we have undefined y values. So there's no graph, no new graph happening less than negative 1. At x equals negative 1 on the original graph, the y value is 0, and so on the new graph, the y value is the square root of 0, which makes the y value of the new function the same as the y value of the original function. And you'll notice that that same thing happens with at x equals 0, where our output is 1 and the square root of 1 is 1. These 2 points will be the same on both graphs. Now, I was interested as to what was happening between negative 1 and 0, so I picked negative 0.5 in my table. On my original function I had 0.5, and so on my new graph I have the square root of 0.5, which if I check that out on my calculator is 0.707. And if I graph that at x equals negative a half, it's going to be here. So what I'm noticing is that the y value on the new graph is a little bit larger than the y value on the original graph. And that would be true for any values of y that are between 0 and 1. So my graph is actually going to go like that on that interval. Okay, let's carry on. So at x equals 1, the y value is 2, so the new y value is the square root of 2, which is 1.414, if you check that out. And so if I plot that at x equals 1, that's approximately there. Root 3 for the next is 1.732, that's approximately there. And root 4 for x equals 3 is there. And what I'm noticing here is that the y values here are smaller than the original y values. And so we've constructed our new radical function by thinking about how the y values of the original function change to become the y values of the new function. And basically there's 4 things that you should be noticing. First of all, where the original function had negative y values, the new function has no points. They have undefined y values. Where the original function had y values of 0 and 1, the new function had the same y values. The third point was where the original function had y values between 0 and 1, which was on this interval right here, the new function's y values are a little bit larger than that. When you square root a number between 0 and 1, you're going to get a number a little bit bigger than that, but not more than 1. So the graph bends up a little bit higher. For y values that were more than 1 on the original graph, which is here, the new y values are less than that, but still more than 1. Because, for example, when you take a y value at a point, for example, the y value is 3, and you square root that, Square rooting that number will give you a smaller number, as long as the original number is more than 1. So here's a summary of what we're saying, comparing the original function's y values to the new function's y values if you square root. If you have negative y values on the original, you have no points on the new function. If you have y values of 0 and 1, you have the same y values on the new function. The points are invariant. If you have y values on the original function between 0 and 1, then you still have y values between 0 and 1, but slightly larger than the original. And if you have y values greater than 1 on the original function, new y values are still greater than 1, but smaller than the original y values. So let's look at how we could apply that to a more complex function. So I have here a parabola with a vertex of 0, -1, opening upwards, and so I'm just going to graph that accurately with some points of accuracy. If x was 2, the y value would be 3. Same with -2. And if x was 3, 9 minus 1 would be 8. So there's my original function. And so we want to create a radical function by square rooting that. And remember, what that means is that for a given value of x, the new y values will be the square root of the original y values. So for example, when I put in 2, on my original function out came 3, the y value of the new graph will be root 3. Here's that point right here I'm talking about, 2, 3. The y value of this will become the square root of 3. The x doesn't change, and that's 1.7. So the new point is lower than it was previously. Alright, let's just go point by point and take into account all the 4 things we talked about on the previous page. So first of all, wherever the original function has negative y values, which is right here, there's going to be no new graph, because you can't square root negative values. Where the original function has y values of 0, the new graph will have the same. So those are points on the new graph. Same thing with y values of 1, which would be here and here on the original graph. Those will also be points on the new graph. Where I have y values between 0 and 1 on the original, which is right here, if I square root numbers between 0 and 1, I get slightly larger numbers, but still less than 1. So my graph will bend out a little bit in that section, but not go above 1. I've already done 2. The y value of the new graph will be root 3. Same thing over here. Square root of 3 is the new point. And let's take this point of accuracy, y equals 8. I just talk to myself when I do this, so the new y value is the square root of 8, which is just about 3, so the point would be about there. It's lower. Y values more than 1 are still more than 1, but less. They're the square root of the original y value. And so trying to connect all that, my graph's going to look something like that. So just finishing off the question, my domain will be x values greater than or equal to 1, or x values less than or equal to -1. And the range is y values that are greater than or equal to 0.